The modern world runs on microchips. These tiny pieces of silicon, often smaller than a fingernail, power everything around us. From smartphones and laptops to cars and airplanes, microchips are the invisible engines driving the digital age. Their importance goes beyond consumer electronics, extending to critical infrastructure, healthcare, and national security. The world has entered the age of the chip, where these miniature marvels hold the key to economic prosperity, technological advancement, and even global power. The story of the microchip is one of relentless innovation and fierce competition. It's a story about globalization, with complex supply chains spanning continents. And increasingly, it's a story about geopolitics, as nations recognize the strategic importance of these tiny technological wonders. The struggle for chip supremacy is reshaping the global landscape, with implications for businesses, governments, and individuals alike. Understanding the chip war is crucial to navigating the complexities of the 21st century. Microchips, also known as semiconductors, are essentially intricate circuits etched onto thin slices of silicon. The process of transforming raw silicon into a functioning microchip is a marvel of modern engineering. It involves hundreds of steps and requires cutting-edge technology, specialized expertise, and significant capital investment. The journey begins with silicon, the second most abundant element on Earth, extracted from sand. This silicon is then purified and transformed into large cylindrical ingots, which are sliced into thin wafers. These wafers undergo a complex series of processes, including photolithography, etching, and doping, to create the intricate circuitry that defines a microchip. The manufacturing process requires extreme precision and cleanliness. Even a speck of dust can render a chip useless. Once fabricated, the wafers are diced into individual chips, tested rigorously, and packaged for use in electronic devices. The complexity of microchip production has led to the emergence of a highly specialized global supply chain. The COVID-19 pandemic exposed a critical vulnerability in the global economy: the over-reliance on a fragile microchip supply chain. As lockdowns swept across the globe in early 2020, demand for consumer electronics surged. People working and studying from home needed laptops, webcams, and other devices. Simultaneously, automakers, caught off guard by the pandemic's impact, canceled chip orders, anticipating a slump in car sales. However, demand for vehicles rebounded faster than expected, leaving automakers scrambling to secure chip supplies. This confluence of factors led to a global chip shortage, disrupting industries worldwide. Car manufacturers were forced to halt production lines, leading to delays and higher prices for consumers. Electronic device manufacturers faced similar challenges, with production delays and increased costs for components. The chip shortage highlighted the interconnectedness of the global economy and the risks associated with concentrated supply chains. It served as a wake-up call for governments and businesses to rethink their reliance on a handful of chip-making giants. The microchip has become a central battleground in the escalating rivalry between the United States and China. Both nations recognize that technological leadership, particularly in semiconductors, is crucial for economic competitiveness and national security. The US, once the dominant force in chip-making, has seen its lead erode in recent years. China, meanwhile, has made significant strides in developing its domestic chip industry, investing heavily in research and development, and attracting top talent. This technological competition has spilled over into the trade arena. The Trump administration imposed restrictions on Chinese tech giant Huawei, cutting it off from vital US chip supplies. The Biden administration has continued this tough stance on China, seeking to maintain America's technological edge and prevent China from acquiring sensitive technologies with potential military applications. The US has also implemented export controls, limiting China's access to advanced chip-making equipment and software. These actions have further fueled tensions between the two superpowers and accelerated the global chip war. Section 5. The Taiwan Question, a global flashpoint. No discussion of the chip war is complete without addressing the pivotal role of Taiwan. This island nation, just off the coast of mainland China, is home to Taiwan Semiconductor Manufacturing Company, or TSMC, the world's largest and most advanced contract chip maker. TSMC's dominance in the foundry market gives it an outsized influence in the global tech industry. Major tech companies like Apple, Qualcomm, and Nvidia rely on TSMC to manufacture their most sophisticated chips. This reliance on Taiwan for critical semiconductor production has raised geopolitical concerns. China claims Taiwan as its own territory and has not ruled out the use of force to achieve reunification. The prospect of a Chinese invasion of Taiwan has sent shockwaves through the global tech industry. Such a conflict would not only disrupt the supply of crucial chips, but could also draw the United States and its allies into a military confrontation with China. The Taiwan question is a stark reminder of the intertwined nature of technology, geopolitics, and global security in the 21st century. Section 6. The Quest for Self-Reliance, a New Chip Race. The chip shortage and escalating US-China rivalry have spurred a global race for semiconductor self-sufficiency. Nations are increasingly wary of relying on foreign suppliers for these critical components and are investing heavily in boosting their domestic chip industries. The US Congress passed the CHIPS and Science Act, allocating billions of dollars for semiconductor research, development, and manufacturing. The goal is to revitalize America's chip-making prowess, reduce its dependence on foreign suppliers, and strengthen its position in the global tech race. The European Union has unveiled similar plans, aiming to double its share of global chip production by 2030. China, too, is doubling down on its efforts to achieve chip independence, pouring resources into building a world-class domestic semiconductor industry. This global push for chip self-reliance is reshaping the semiconductor landscape, leading to increased competition, innovation, and investment. Section 7. The Future of Warfare. Chips on the front line. The significance of microchips extends beyond the economic and technological realms. They are also becoming increasingly critical to modern warfare. Advanced weapons systems, from fighter jets and drones to missile defense systems and cyber warfare tools, rely heavily on sophisticated microchips. As militaries around the world modernize and embrace artificial intelligence, the demand for high-performance chips will only continue to grow. This growing military dependence on microchips has profound implications for national security. Nations with access to advanced chip-making capabilities will have a significant strategic advantage. They will be able to develop and deploy more sophisticated weapon systems, giving them an edge in any future conflict. The chip war, therefore, is not just about economic competitiveness or technological leadership, it's also about shaping the future of warfare. Section 8. The Innovation Imperative, Beyond the Chip War. While the current chip war is undoubtedly a cause for concern, it's crucial to remember that the semiconductor industry has always been characterized by intense competition and rapid innovation. The current geopolitical tensions, while challenging, could also spur a new wave of innovation in chip design, manufacturing, and applications. Governments and businesses are investing heavily in research and development, seeking to develop faster, more efficient, and more powerful chips. This drive for innovation could lead to breakthroughs in artificial intelligence, quantum computing, and other transformative technologies. The key to navigating the chip war and harnessing its potential benefits lies in fostering international collaboration and open dialogue. While national security concerns are understandable, excessive protectionism and isolationism could stifle innovation and harm the global economy. A more collaborative approach, focused on sharing knowledge, coordinating research efforts, and establishing common standards, could unlock the full potential of microchip technology for the benefit of all. Section 9. A world rebalanced chips and the new global order. The chip war is a symptom of a broader realignment in the global order. The post-Cold War era of US hegemony is giving way to a more multipolar world, with China emerging as a major economic and technological power. The struggle for chip supremacy is both a reflection of this shifting balance of power and a catalyst for further change. The outcome of this competition will have profound implications for the global economy, the future of technology, and the balance of power in the 21st century. The chip war is a complex and multifaceted challenge with no easy solutions. It requires a nuanced understanding of the interplay between technology, geopolitics, and economics. As the world becomes increasingly reliant on microchips, the stakes will only continue to rise. Navigating this complex landscape will require careful diplomacy, strategic thinking, and a commitment to international cooperation. The future will be shaped not just by the chips themselves, but by how we choose to manage the competition and collaboration they inspire.